Today, we are diving deep into the science of climate change. We're going to break down how our planet's climate system works, how we know it's being thrown out of balance, and what that actually means for all of us.
You've heard this before, right? Someone's grandpa or aunt saying, the winters just aren't what they used to be. It sounds like a casual comment, but these little personal observations are actually a doorway into a much, much bigger story.
These stories, let's call them climate stories, are so important. Whether they come from farmers or fishermen or just from our own families, they help connect the dots between all the scientific data and our own lives. They really put a human face on all the numbers and graphs.
So, to understand why those stories are changing, we have to start with the basics of Earth's climate engine. First things first, what even is climate?
Right, so it's definitely not just today's forecast. Climate is the long game, the big pattern. Think of it less like a daily snapshot and more like a 30-year-long movie of our planet's weather. And the engine driving that whole movie? It all comes down to energy.
And here is the absolute key. For our planet's temperature to stay nice and stable, the energy we get from the sun has to equal the energy Earth sends back out to space. It's like a planetary energy budget. And just like with your bank account, if you have more coming in than going out for too long, well, things are going to start to heat up.
Now, as you can see from this map, that energy isn't spread out evenly. The tropics get way more heat and the poles get way less. So to balance things out, the atmosphere and the oceans act like a giant circulatory system, constantly moving all that heat from the equator up towards the poles. This global flow is what gives us everything from deserts to ice caps.
For thousands of years, that system has had its own natural rhythm. But now, that energy budget is being pushed out of balance, and it's happening at a speed we've never seen before. Let's take a look at what that really means.
So when you hear scientists talk about climate change, this is what they mean. It's not just one hot summer or a couple of mild winters. It's a deep, long-term shift in the entire system, a change that goes way beyond what we'd expect from its natural ups and downs.
And here is the big difference today. For the first time ever, a single species, that's us, has become a main driver of these changes. The scientific word for it is anthropogenic, which is really just a fancy way of saying human-caused. By pumping heat-trapping gases into the air, we are fundamentally messing with the planet's energy budget ourselves.
Now, what's amazing about this slide is how clearly it tells the story. On the left, you've got global temperatures since 1850. On the right, greenhouse gases. Just look at how they track each other. They both just shoot straight up. That sharp turn, that's the fingerprint of the Industrial Revolution.
So how can we be so sure this is unprecedented? How do we know what was happening thousands or even hundreds of thousands of years ago? Well, that's where the incredible science of paleoclimatology comes into play.
You can think of scientists as climate detectives. They're trying to piece together Earth's medical history to understand how its systems work. And to do that, they look for clues hidden away in nature itself.
And one of the most amazing natural archives is ice. As snow falls year after year in places like Antarctica, it compacts down into glacial ice, and it traps tiny, tiny bubbles of the atmosphere. So by drilling deep down, we can pull out these ice cores that have perfectly preserved samples of ancient air going back hundreds of thousands of years. It's incredible. So what do these ancient air bubbles tell us? Well, they show that for almost 1 million years, CO2 levels naturally went up and down with the ice ages. But, and this is key, they always stayed within a certain range. Never below about 180 parts per million and never above 300. That was the natural ceiling.
Okay, now let's zoom in a bit. For the last 2,000 years, the entire period where human civilization as we know it really got going, CO2 levels were incredibly stable, just hanging out right around 280 parts per million. It was this predictable climate that allowed farming and cities and everything else to flourish.
And then this happened. Since we started measuring directly in 1958, that line has gone nearly vertical. We have blasted past that 300 ppm natural ceiling, and now we are way, way into territory our planet hasn't seen for at least 800,000 years. This isn't a natural cycle. This is something new.
So what's driving this? This number, 40 billion tons. That is how much carbon dioxide, human activities, mostly burning fossil fuels, are pumping into our atmosphere every single year. That's the staggering weight of the change we're creating. Tipping the planet's energy budget this far out of balance has real, tangible consequences. So what happens when you pour that much extra energy into the system?
Well, the effects are all over the place. All that extra heat is melting ice and causing the oceans to physically expand, so sea levels are rising. It's also supercharging our atmosphere, which leads to more extreme weather. Ecosystems are being forced to move, and it's even affecting the spread of diseases.
Right now, the global sea level is rising about 5 millimeters every year. Now, I know that doesn't sound like much, but the key thing is the rate is getting faster. Over decades, that adds up to a huge change that can redraw coastlines and make storm surges so much more dangerous.
This is just basic physics, really. More heat equals more energy, and a more energetic atmosphere can hold more moisture, which fuels more powerful weather. So you get more intense heat waves, stronger storms, and the kind of dry conditions that lead to devastating wildfires all across the globe.
Okay, the science is clear, the data is pretty stark. So the last and maybe the most important question is, where do we go from here?
The scientific community points to a pretty clear path. First, we have to cut greenhouse gas emissions, and we have to do it fast. Second, we can all foster conservation to just reduce our demand for energy in the first place. And third, we have to embrace what we humans are best at, innovation. We are creative, imaginative, and incredibly adaptable species, especially when we're facing a major challenge.
You know, for all of human history, our societies have been shaped by the climate we live in. Now, for the first time, our climate is being shaped by the actions we take. The science tells us where we've been and where we're heading. The only question that's left is, what story are we going to write for the future?